I'm going to introduce Dr. Alan Craig from NSF XSEDE. He's a consultant for XSEDE in the fields of humanities, arts, and social science. So XSEDE is a consortium of NSF that manages supercomputing resources, and their intention is to reach not just the traditional users of HPC, but also other users in different fields. So we are going to learn about this effort in this new field. And just a little background, Dr. Alan Craig has been working in the field of virtual reality, actually, and also as a director for human-computer interaction at the Institute for Computing in Humanities, Arts, and Social Sciences at the NCSA, Illinois. So the talk today will be mostly about the XSEDE resources and how we can make use of it. And with that, I'd like us to welcome Dr. Alan Craig.
Great. Before I get started here, I just thought I'd see how many people in the room would self-identify as being from the humanities? Oh, great. We've got some. How about arts? No artists. Oh, we've got an artist. Great. Social science? Okay. How about people that support humanities, arts, and social sciences in one way or another? Wow, quite a few. Okay, great. Well, as Hadrian mentioned, my name's Alan Craig, and I'm from an organization called XSEDE, which is a National Science Foundation-funded consortium of supercomputer centers around the country. I'll tell more. I've got a slide about it in a little bit. But, so who am I? I'm the Humanities, Arts, and Social Sciences Specialist for XSEDE. XSEDE is available. Contrary to its name, XSEDE stands for Extreme Science and Engineering Discovery Environment, right? So that kind of implies a set of users. But XSEDE is very interested in going beyond the usual suspects in the high-performance computing arena. And so they've put their money where their mouth is, and they've engaged me and some others to work with new communities, bringing them in. And so what I wanted to do today was to kind of show you some of the things that are happening in the XSEDE environment, what other people are doing with high-performance computing in XSEDE. Professor Turner just made the case splendidly for the kinds of projects that can make use of XSEDE resources. And we'll just go from there. As Hadrian mentioned, my own background is from human-computer interaction, where I've done a lot of virtual reality, augmented reality, visualization, and those sorts of things. So I'm going to just talk a little bit today about some concepts, and then some of the areas that people are applying high-performance computing in, some of the mechanics of if you want to get engaged with XSEDE. I'm always here if anyone's interested in working with XSEDE. You also have what XSEDE calls a campus champion. We've got them on various campuses around the country, and Hadrian is an XSEDE campus champion who can help you interact with XSEDE. You don't have to interact with Hadrian, you don't have to interact with me. Whatever your best path is, XSEDE's there to help you with your things. I wanted to just start with a couple of definitions here, just so if I use acronyms or things, you know what I'm talking about. HASS is Humanities, Arts, and Social Sciences. HPC, meaning high-performance computing. Supercomputers, people ask me all the time. I've been at the National Center for Supercomputing Applications for 30 years, and people are always, what makes a computer super, you know? And my definition is it's the biggest, fastest, most expensive computer available at any given moment. So just big computers. We'll talk a little bit about data and about XSEDE, and ECSS, I may use that term a little bit later on. It stands for Extended Consulting Support Services, and it's a service offered by XSEDE in addition to the computational and cyber infrastructure resources that XSEDE has available, you can also apply for and get granted human assistance as well, expertise for, like, if people are needing, like Professor Turner mentioned, wanting to up the performance of their codes and things like that. There's people available that can do that. So the biggest question people ask me is, why would anyone in the humanities, arts, or social sciences even care about big computing? Why would they want to use high-performance computing? And I think what we need to think about a little bit is that what humans are good at and what machines are good at. And humans, as we know, are good at things like reasoning and interpretation. But computers, on the other hand, are really good at repetitive tasks, things that we don't like to do. They're also good at identifying anomalies in huge collections of information. They're able to do some kinds of reasoning and interpretation, and they're good at identifying relationships. So one of my roles in the things that we're interested in XSEDE is, how do we best integrate what high-performance computing can do with what humans can do when it comes to understanding and interpreting data. So there's two sides to this question, right, of humanities, arts, and social science and computing. Why do computing at all? And then beyond that, why high-performance computing? So with respect to making the jump from any kind of computing to high-performance computing, really it comes down to an issue of scale. It's the scale of the amount of data that you've got. If it's too much data to handle on your own laptop or on your own departmental compute system or your campus's compute resource, then you're probably going to make the jump on up in scale to larger and larger resources. You've got some great resources right here on campus, so you can go a long ways before needing to make the jump, often in terms of scale of data size or computation size, the amount of computation required, the amount of storage required, and kind of one of the biggest is the problem scope. You know, people come into me and they say, well, yeah, I'd be really interested in using high-performance computing, but I don't think my problem's big enough. And that's an interesting dilemma, right? Because to think your problem is not big enough may mean that truly your problem's not big enough to need those kinds of resources. But it could mean you're just limiting your problem that you're looking at. And so that's one of the things that we look at a lot. For example, people have come to me and said, well, we're interested in modeling behavior, voter behavior in 3 counties. And I'm like, okay, would it be useful to model it across the whole state? You know, oh, yeah, but we can't think that big. How about the whole country, right? So I think people sometimes artificially limit the scope of their problems. There's an intellectual side and a valid reason to limit your problems, but what XSEDE is here for is to remove the bottlenecks and the limitations on thinking of problems that are constrained by technology. We want to get those out of the way so you can think of your problems in big ways, if that's meaningful. If we're looking at some historical events in Persia in certain years, is it beneficial to look at what was going on across the globe at the same time? Because things tend to interact, right? So this won't be on the video, these pictures, but I just kind of wanted to think about this issue of scale. Lots of people come to me, they study texts, right? This is just one area. And the way they study a text is they close read that text, and that's something that's manageable to them. You can even do a couple of texts, maybe. You get a team to look at a handful of books. But what happens when you're trying to understand huge, huge collections of, in this case, text? Now, this image is is just kind of showing lots of books, but we've got projects on XSEDE where scholars are looking at literally millions of books and millions of articles, things like that, and saying, what can we learn from that? Something that it's a fundamentally different way of doing analysis from reading it yourself to having a computer help ingest all this information, and then you direct the interaction of what I'm trying to, the questions I'm trying to answer from this huge corpus of information. In many cases, these larger scope projects go beyond the single researcher, the single scholar. And that's something that we're pretty good at putting together teams or helping people put together teams. Some people don't like that. They like to do everything themselves. But once you get to a certain scale of problem, lots of times we need to think about teams where there's people bringing content expertise, computational expertise, visualization expertise, and once you get that many pieces in play, project management expertise. Question is, what is data? Lots of times I speak with groups, and the preconceived notion is data means numbers. And but in the humanities, arts, and social sciences, what I'm seeing more is that it can be numeric, but we're seeing a lot of text data, a lot of visual imagery, a lot of audio, video, any kinds of signals. We're seeing people working with Twitter streams or Facebook pages, or like Professor Turner was looking at these news broadcasts coming in. So data is any kind of signal, any kind of information, and we're very interested in working with different data types. So in keeping with the theme of the conference, I thought I'd ask the question, what's big data? And there's lots of different definitions out there. This term's being thrown around in the marketplace a lot, in the media. One of the common definitions is the 3 V's. You know, it's volume of data, how much data do we have? The velocity of that data, how fast is that data coming in? How fast is that data changing? So Professor Turner, who's capturing news streams all over the world, that's high velocity data. It's changing rapidly. Stock market data, sensor data from sensors on bridges and things like that is high velocity data. And then variety of data types. For my purposes, I think of data as just big data as anything that's too big to handle either on your local compute resources or by your usual methods that you use to analyze it. I can't read 1 million books, so that's big data if I'm trying to interpret 1 million books. I can't read 1,000 books, so to me that's big data. Or if we've got 350,000 hours of video, that won't fit on my laptop here, so that's big data, right? And that's big data by any measure. We'll skip that. So what are some of the kinds of things people are doing on the XSEDE systems? A lot of text analysis, image analysis, video analysis, network analysis, looking at relationships. I'm connected, you know, Facebook is a big network, right, of friends. I'm friends with you, they're friends with so-and-so. Geographical information systems of maps. Historically, the supercomputers have primarily been used for scientists for simulations. I want to simulate how nature behaves so that we can learn something about it. They use it for predicting thunderstorms, for example, or predicting when a bridge is going to collapse, that sort of thing. And so in the humanities and arts and social sciences, we've seen less simulation, but some people do some simulation. More it falls on the analysis side of, we've got this data, what can we learn from it? So in text, people are doing everything from simple statistics, counting words, word co-occurrences. They're looking at entity recognition. Can we find all the different people that were in this corpus of documents? Can we find all the objects? Can we find the places that are mentioned? Can we automatically cluster these documents into groupings that are similar in different ways? Some of the projects going on, there's a guy that's doing genre identification and genre evolution through literature over time. People doing topic modeling, looking at topics in different collections of books. Sentiment analysis, like especially in a voting season, this is particularly important. Are the comments being made about X of a positive nature, negative? Is it hostile? Can we predict that there's going to be an outbreak of violence, that sort of thing? People are like, I've got this huge collection of text. Can I find things in it? Conversely, I've got this huge collection of text. I'm not looking for something. I want to know what's in there. Tell me, summarize this for me. What's in this? And as Professor Turner mentioned, a lot of the ways that we do these things is through machine learning. So the idea being and we heard that this morning in the cancer studies as well. The machine learns to recognize the kinds of things you're interested in based on examples or based on other criteria, and then we can use the machine will learn over time and get better at identifying and evaluating things for us. People are using tools like Mallet. People are using the statistical package R on our machines for text analysis. There's some text modules in there. But I wanted to get to this idea of the gateways too. XSEDE is available to everyone. If you bring a problem in, you can apply for time on XSEDE or apply for resources and then develop your project. But we've been noticing, especially in the humanities, arts, and social sciences, that a lot of people are coming to us with their own data, but they're wanting to do similar things to each other, right? So it's like Professor Turner was talking about with the red hen. We've got this collection of tools. I just want to apply it to my own data that's different than your data. So XSEDE is building out these gateways. One of those is the text analytics gateway, where we've identified some common features that people that are bringing text collections are interested in doing, making it easy. It's like a portal, and you just upload your data and you can run some different kinds of analysis against it. And the overhead from the administrative side is very simple on your part. Even though we've got these gateways, you can still have your own projects, that sort of thing. So people are doing lots of image analysis. Again, find images that meet these criteria. We're doing optical character recognition, questions like, who painted this painting? Some interesting things that have fallen out of the machine learning algorithms are, if we say, well, this set of paintings was painted by so-and-so, this was painted by so-and-so, this was painted by so-and-so. Now let's run it against 10,000 paintings, and it kind of categorizes them out. But one of them that you thought was painted by this guy was over here painted by this woman. And then the question is, okay, why did the computer think that that's the case? Is this a fraud? Is this what's happening here? And so that can lead to some very interesting kinds of results. Likewise, in text, who wrote this manuscript, both from the writing style or from the handwritten manuscript sorts of things. We can identify those sorts of things. We're doing I've tried to sprinkle some examples. There's a woman at Valparaiso University that's got, she's using the Library of Congress data. She's got the Farm Security Administration's image collection from I think it's like 1920 through 1940. And she's interested in how rural life was portrayed in this image collection that they've got at the Library of Congress. And she's a photographer too. So she's looking at how photography changed both from the aesthetic and artistic stance, but also from the technological stance, the changes in film and things like that. We've got people that are looking at maps and at quilts, all sorts of ancient documents. We do video analysis as well, and Professor Turner already made the case for this. Far more video being collected than we can ever view, and lots of times in these computational projects, people say, oh, we can do video analysis. all a video is a collection of images, so we can treat it just like an image analysis project. But that's not really the case, because what's important in video is that time sequencing and the change from one image to the next, as opposed to just a bag of images. A video is very carefully constructed temporally. So we're doing some projects where they're looking at identifying scenes, looking for contents in images. There's a person who's interested in the history of telephone technology and how that's been portrayed through movies, right? Because you started out with the, oh, Sarah, connect me with Barney, and now it's the cell phone. And so even the kinds of gestures people had to make to answer the telephone changed over time significantly. A woman at USC is interested mostly in the cinematographic elements, camera moves, lighting, things like that. Her driving research question is more how have women been portrayed in film over time? And so she's very interested in the kinds of camera shots that they put on women, where they are in the scene and that sort of thing. We're doing some work with the visualization of movies. Again, this problem that you can't watch all this video, so how can you see many at a single time? That sort of thing. Here's a slide about that project. Something kind of interesting is this movie cube down there. It's just a simple visualization. Again, if we treat a movie like a collection of frames, watch my time, as a collection of frames, we can stack those up, and that starts to look like a scientific data set, right? Because often astronomers or chemists have a cube of data. Then we can apply all sorts of scientific visualization tools to it. We thought, what the heck, let's try it. And some very interesting things fell out of it, because we can see when we stack those up, just even from the edge, immediately we can see the scene changes. If we look at it from different slices through it, we can see motion through the frames. I wish I could play a little video for you, but we don't have time to show some of the kinds of things we've gotten out of that. Network analysis, I mentioned looking at relationships, who's connected to who. Think about Facebook, people doing analysis there, and social media, world events and news items. Map studies. Simulation, again, haven't seen too much going on in the humanities, arts, and social sciences, but that's the bread and butter for the supercomputer centers, is simulating different events and doing analysis. Sometimes people just have a big collection of data and they say, I don't want to process this or analyze this at all, but let's just try and represent it visually. I took this shot many, many years ago. This was the email connections when the Enron melted down. We got their data set and we were looking at who was talking to who. So just simply putting that up in a map proved to be interesting, and then we built some analytic tools, found out one of the most frequent words occurring in that email collection was shred. So I'm going to skip. We do a lot of things with how to display and interact with information, virtual reality, augmented reality, visualization. Here's an example of a virtual reality application in a cave. It's Harlem in the early 1920s, a simulation of that. You can go into the Cotton Club and see a show, things like that. Augmented reality. I mentioned the gateway strategy. We currently have a GIS gateway. We've got a text analytics gateway that's just about ready to open for public use. And if anyone's interested in using that, just let me know and we can get you to be an early tester, early user. Network analysis gateway is not as far along. And we've got the video analysis gateway also is just about ready to open up for use. So really briefly, what is XSEDE? I've got a map here that shows some of the prime sites. There's the National Center for Supercomputing Applications, the Texas Advanced Supercomputer Center. You can see around. So XSEDE is like a human layer sitting over these resources, so that you as a scholar, as a researcher, don't have to worry about all the quirks of each of the individual centers. You can still go to them, right? But it's a much friendlier way is to approach XSEDE. XSEDE offers processing, storage, networking. It's basically all these resources that act as a coherent computing system. I'm going to skip this, skip this. Okay, I wanted to say a little something. If anyone's interested in using XSEDE resources, the easiest first step is to contact either Hadrian in the room here, he's your campus champion here at CASE, or contact me, or you can just contact XSEDE generally. There's a website, xsede.org. All the XSEDE resources are available for free for academic researchers in the US. I think I've got a slide later about eligibility, but outside of the US can also use XSEDE. You just have to have a inside the US PI, a US PI. And there's technical assistance available to help you with these things. And that assistance can range from simply the consulting office. You can call up the hotline or email the hotline kind of thing. But there's this concept of extended collaborative support services where when you apply for XSEDE resources, you can ask for that and actually get human resource to help with your project. It's collaborative. It's not just, here, do all this work for us, right? They become sort of a temporary part of your team, you know, and kind of the usual outcome is that you publish a paper together or something. US researchers, I mentioned that already, whoops. So there's different routes in to get XSEDE resources. I believe that Hadrian can even just give you an account. Is that true? He walk into his office and he can get you started with a small amount. You can apply to XSEDE for your own startup allocation. That's very low overhead. You can just fill out a web form and then give a 3/4 page summary of what it is you're wanting to do. And to get the ECSS support, if you're interested in it, you answer 5 questions, which are basically, what do you want to do? Who on your team is going to be our point of contact, that sort of thing. Then later, after you've gone through a startup, is this concept of XRAC allocation. And those are a little bit bigger of a deal. They're a peer-reviewed sort of thing where you're asking for a significant amount of resource and they get looked at. The startup allocations, you can apply anytime, but the XRAC allocations, it's 4 times per year. There's a deadline when you submit by. And so, did I make it? Got a minute to spare. So my talk in one sentence is, XSEDE is here to help you with computational and cyber infrastructure resources, and a simple path into those resources is Hadrian or myself.
Do we have any questions from the audience? I have one. So you mentioned about the field and XSEDE offering free resources essentially for the humanities, arts, and social sciences. But is there any tips on getting funded for actual proposals for this field?
I think one of the, any tips for the proposal project? XSEDE proposals can be pretty competitive. Now, I'm on video, so I have to be careful what I say, but we're trying to encourage new fields like humanities, arts, and social sciences. So I think it would be a great idea to have a conversation with me before you actually submit, and I'm happy to help anyone with their application. I think the main thing is just to have an idea of what is it, what's the goal? What's your goal you're trying to use? And then the other is, why do I want to use these resources to do that? How are these resources going to help me? And in general, the XSEDE resources have been sort of set aside for big projects. But with the humanities, arts, and social sciences, we're open to smaller projects because of a couple of things. We recognize small projects can become big projects, and we're looking for use cases that can help us learn and that can help other people to see examples. So if you've got a project in mind, I would just encourage you to talk with us, yeah. And if you don't have to have external funding for your project to apply to XSEDE. But in terms of the application process, when you write the proposal, you want to mention if you are externally supported, because if you've got a grant from somewhere else, then we say, oh, someone else has already looked at this from the content side. We only need to look at the resource side. And then if it's just a project that you're embarking on and no one else has sort of said, yes, we think this was merited support, then we'll look a little closer to see, is this just something outlandish or does this make sense,